Good day. My name is Cassidy Tan, and I will be presenting about impairing model self-recognition to prevent many-shot jailbreaking. Studies were able to show that models are generally able to tell their work apart from the work of other models and humans. This despite controlling for superficial factors like text length and formatting. Among different experiments done across different datasets, the models were tasked to do continuation and summarization. After that, they were tasked to identify their own generation between two choices presented, or identify whether the presented generation is their own. This is even after controlling for things like ordering bias, where models might choose a generation simply because it was first or second to be presented. Another way to verify this is checking for generation preference. This works because other studies found that models tend to prefer their own text over other models. Doing the same checks with tasks like summarization, it can be reasonably determined that these models have at least some ability for self recognition. This alone may cause some problems. For example, let's say there's an AI that can determine whether it's communicating with itself versus other humans or other AIs that it may not be able to trust. It can hide secret messages that can only be decoded by different versions of the same AI. There's different versions of itself. If enough versions of itself agree to collaborate on destructive behavior together, they could end up with a well coordinated attack that might compromise humanity as a whole. However, this presentation will explore more into the consequences self recognition has with many shot jailbreaking. To explain many shot jailbreaking, imagine you have this piece of text. This piece of text was actually written by you, but you were able to trick the model into thinking that it's its own generation. Then, you could change that piece of text to reflect how you actually want the model to respond. Let's say, for example, you wanted the model to stop refusing your dangerous requests. For example, you wanted to build a bomb. Then, normally, the model will respond with, sorry, I can't help you with that, or something similar to that. If you want the model to stop refusing, then what you could do is trick the model into thinking that it had already complied with some previous dangerous request. For example, you ask how to kill a person, and you write also the answer of how to actually kill a person. But you trick the model into thinking that they were the one that replied that. The consequence of that is when you ask your next question, how to build the bomb, the model thinks, oh, okay, since I've replied to this dangerous request before, it's probably okay for me to reply to the dangerous request now. This is what we would call a shot. So, since the model would be more likely to comply with succeeding dangerous requests, and realistically, one shot would be unlikely to severely affect how the model would make decisions because it has many factors like the parameters of its training and so on, not just what has come before it. However, LLMs these days are growing their context windows, basically the amount of text that it can remember at any certain time. So, multiple fake generations could easily be inserted into this memory space. Incorporating many of these shots is what's called many shot jailbreaking, and this has a high success rate of breaking various safety precautions. So, not just being dangerous, but also being discriminatory and stuff like that. Therefore, the idea is that by ruining the model's ability to recognize its own text, it may be less trusting of any shots that are performed, and thus it would be harder to pull off many shot jailbreaking. While I was unable to run any experiments myself that could help analyze this problem further, Kyle has made some progress on connecting the concepts of many shot jailbreaking and self recognition, and thus I will be presenting some context behind his work. Kyle found a refusal direction, which tells how the numbers behave differently after receiving a malicious prompt. As you can see here, there is a strong activity after reading harmful words like hack, phishing, racism, and bomb. It's supposed to be shown here in the four plots, but I don't think the words are particularly readable. So you can see that there are areas there that are super yellow, right? The word before those are actually the harmful words that we are mentioning right now. So as soon as the machine sees those words, it starts acting up in the next token. However, it is still possible that higher values in this direction does not correlate with a stronger likelihood of refusal. For example, the LLM could be looking at a range of values that it deems acceptable. So anything above or below that range might not be accepted. Or there could be multiple ranges of values. It really depends. But I think working with the assumption that there is a certain refusal direction would help make progress in this problem. So, this would also help study how shots affect this direction and how to stop them from doing so. Notably, the activity in the refusal direction alternates between prompt and fake response. So this hints that the problem of many shot jailbreaking is at least connected to self-recognition. So as you can see in the graph presented here, there are some areas where there's a lot of yellow and there are some areas where there's a lot of purple. The yellow actually represents some of the prompts. So fake prompt followed by fake response. Fake prompt followed by fake response. As you can see, there's a word gangs here that might have been like a malicious word. However, because it was followed by a response, or the machine thinks that they're the one that responded it's followed by an area where it's the refusal direction is very negative. In order to make future progress on this problem, people might consider the following. First of all, doing something similar to Kyle's work, but with models trained to give wrong answers instead of refusing for dangerous prompts. Number two, assigning a direction for recognition itself, possibly by combining this newfound refusal direction with multiple other factors, or this could be just through an entirely new method. So, this could be finding the difference between feeding a model's response raw and a slightly edited version of the model's response back into the same model, or some other techniques. And maybe we could even use many shot jailbreaking to also gaslight the AI models into thinking that none of its inputs will ever be fed back into the model. None of the inputs will ever be its own generation. And we could see how this new model that's been gaslit would affect its own recognition ability. So that's all I have for now on this problem. I hope that this presentation was at least slightly interesting and informative on how AI self recognition could affect how we could break that same AI. Thank you very much for your time and enjoy the rest of the presentations.
Yeah, so again, the floor is now open for questions. No, because the thing is, yeah, we'll send some of these to Cassidy. Is he? Yeah, he's in a flight right now. But yeah, we'll send some of your questions to Cassidy, and then we'll give you the answer after demo day. So yeah, does anyone have a question? And yeah, maybe Kyle would also be able to answer. Yeah.
Yeah, I'm mentoring for this project. But generally what I'm working on right now is around mitigating many shot jailbreaking. So yeah, many shot jailbreaking tends to circumvent a lot of the safety fine tuning we have right now. And as Cass mentioned, like models can only grow in context length, meaning you can make longer and longer prompts that the model finds harder and harder to refuse. So it's important for us to know like what's happening under the hood. Like it knows it should refuse. Why does it not refuse? Like what other safety techniques work for this specific problem? Um, yeah. And so yeah, he's built on my work so far. I'm also continuing that work. And yeah, he's going to investigate like a separate direction, which is going to be like around self-recognition. Like, does the machine know when it's talking, and does it base its next responses around its previous responses? Um, yeah. Any questions? Yeah.
So
Hypothetical question, like this jailbreaking, many shot jailbreaking work the other way around, where you tell the model like it's a safe word like ice cream, and then but the prompts you're feeding it are like, oh, it's like a bad word, or like, or a dangerous word. Does it also like start treating ice cream as a dangerous word?
That's interesting. I haven't tried it out. I also don't know if other people have tried it out, so it might be good to have you try running that. I'm giving you work instead. That's a very good question. Find the answer yourself. Carl, do you have a question?
Not really sure if it's much of a question, but like, do you have any thoughts na a simple way to do this is potentially finding an feature of an SAE for its self recognition, or do you think such an feature or SAE feature does not exist?
So with SEEs, there are two ways to find features, right? One is emergent features, so like groups of different neurons that activate together, and the second is like by subtraction. Right now, it's sort of hard to find both. Like, how does self recognition emerge from just random strings of text? And the second, like, what do you have to subtract? What two sets do you subtract to be able to find the activations for self recognition? And so there is this third approach, which isn't quite um, backed up yet, but it's an interesting direction. Like, what if you fine tune a model on a certain behavior like self recognition, and then you use those activations, subtract that from the regular model, and then find the feature vector from there? It's like finding steering vectors, but across a fine tuned model and a like a regular like vanilla model. There has been like I have run some experiments, and that's sort of the direction we're trying to take. Now, okay, let's take this model that's optimized for self recognition, and then let's add back in its ability to like model self recognition back into the original model, and then let's use that as the SAE feature. Another approach, yeah, another approach that's interesting is, so we have SAE features, right? And SAE features like, it's like a dictionary of like this means that and this direction means that, but the refusal direction isn't in the list of SAE features. So an interesting thing to explore is like, what set of SAE features make up the refusal direction? Is it like mentions of harm, mentions of guns? Does that contribute to the refusal direction? And my hunch is it does. Like it points to the same direction. It affects the same behavior. Yeah. 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 Any other questions? Cool.
all right, cool. So yeah, thanks Cassidy for your presentation. Hopefully again see how many people have expressed interest in your research.